Welcome to today's class. We are still handling relative atomic mass as calculations on relative atomic mass. Alright, we have an example on the board. An element Y exists in two isotopic forms. Y mass number 89 and Y mass number 40 in the ratio 3:2 respectively. What is the relative atomic mass of the element? Alright, if you look at this very well, you notice that in place of relative abundance, the ratio is given. So what do? We still have a formula that can help us solve this. For us to do that, we apply the formula relative atomic mass is equal to capital letter A times small letter a plus capital letter B times small letter b all over small letter c, where the capital letters represent the mass numbers of the respective isotopes, and the small letters represent the ratio, while C, small letter c, is the sum of the ratio. Okay, so capital letter A or letter A for the first isotope of the element, letter B for the second isotope of the element. So by substitution, this will give us capital A is 89 times small a is the ratio of the first isotope, which is 3, plus capital letter B represents the mass number of the second isotope, which is 40, times small letter b is the ratio of the second isotope, which is 2, all over c is 3 plus 2. Alright, the 89 times 7 will give us 117 plus 40 times 2 will give us 80 all over 3 plus 2 will give us 5. And when you sum this up, this will give us 197 divided by 5. I want to believe if you punch your calculator, you have 39.4. So the relative atomic mass of this element is 39.4. Remember, you only apply this formula when the ratio is given in place of the relative abundance. Alright, we take example number 2. Example number 2. If an element R has isotopes 60% R with mass number 12 and 40% R with mass number X, and the relative atomic mass of R is 12.4, find X. In other words, we are looking for the mass number of the second isotope, which has the relative abundance of 40%. Okay, for us to solve this, we apply the formula relative atomic uppercasing letters represent mass number, the lowercasing letters represent relative abundance of the isotopes. Okay, so A, by substitution, our A will be 12 times small letter a, 60% plus B is X, which is what we are looking for, times the proportion, which is 40 all over 100. Remember, I told us in our last class that the reason why we have 100 is because of the fact that the summation of the relative abundance will always give us 100. So 60 plus 40 gives us 100. Alright, now relative atomic mass is given as 12.4. So here will give us 12.4. So now having 12.4 equals to the first bracket and then the second bracket all over 100. 60 times 12 will give us 720 plus 40 times x will give us 40x all over 100. Okay, since we are looking for the value of x, we cross multiply, and when we cross multiply, that will give us 12.4 times 100 equals to 720 plus 40x. 12.4 times 100, we have two zeros, so we move two decimal places to the right, and that will give us 1240 equals to 720 plus 40x. We are looking for x, so we take this over, and that will give us 1240 minus 720 equals to 40x. Of course, I want to believe you know that when a positive number crosses over, it becomes a negative. That's why here we had 720, positive 720, and crossing it over gives us a negative 720. You do the substitution, that will give us, this minus this will give us 520 equals to 40x. We are looking for x, so what do? We divide both sides by the coefficient of x, which is 40, and that will make x stand alone. So x is equal to 520 all over 40, and if you work this out, this will give us 13. This will give us 13. 0 cancel 0, 52 divided by 4 gives us 13. Therefore, the value of x is 13. The mass number of the second isotope of the element R is 18. Thank you very much for watching. Do well to subscribe if you're coming across my video for the very first time. Like, comment, and also share. Bye.